Hello everyone. Today we will talk about CAN bus boards and what is the advantages of the CAN bus boards. So let's start with explaining with what is CAN bus. CAN bus is a communication protocol, and basically there is a two power cable for the positive and the ground and two for the data. So with four cable you can communicate the devices which are connected to this CAN network. They are connected parallel. It's using the device ID to collect or send information or data. So that means that with four cable, you can control and you can get the data from other connected devices to this board. And Clipper has a native support on the CAN bus, which means that we can connect boards which can be communicated with the CAN bus. The first came in the page is a HUVUD board made by Bondus. I think with his development also CAN bus protocol is implemented in the Clipper, but I'm not sure. So what is HUVUD? Let's continue with that. So HUVUD is simply a small motherboard for the printer. It has only one stepper drive, which is TMC2209, and this is for the extruder. Actually, it can be used for any other stepper motor also, like X, Z, Y. It doesn't matter which one it is. But yeah, this motherboard is actually designed for the tool head, basically. So the dimension is the same. The dimension is same with the stepper motors that we are commonly using in the 3D printer. So the idea is you are just removing the screws of the stepper motor in the backside and put some spacer between board and the motor so you can isolate it. Then again, you are with the using same threads, I mean inside of the motor, you are mounting your board on the back of the motor. So that means that it's yeah, the purpose is seems like that. But like I said, you can use this board, for example, XMY motor. Doesn't matter, but yeah, if you ask me for XMY or Z motors, it's just a bit overkill because it does not have only the stepper drive. By the way, this is the 0.50 version. Nowadays, I think it's released the 0.61. I will also mention what is the difference. But let's continue with that. This board is this board has actually other inputs and outputs. For example, this one is the output for the heater, and these two are for the fans. For one for cooling fan, one for hot end fan, and this is for the thermistor, which were reading the temperature of the hot end part, and these are the end stop, and this is for the extruder, by the way. So that means it's actually designed for the hot end, but it can be used for driving other stepper motors. And what is the advantage? So the advantage is instead of running wires for the two for heater, four for fans, two for thermistor, and yeah, you might not be using end stop, but instead of 8 wires, at least you need 8 wires on the 8 wires on the hot end. Instead of running 8 wires from the main motherboard to hot end, I mean tool head, you just need only 4 wires. Two for power, two for data. That's all. That's the advantage of it. So for the disadvantage, to be honest, I'm using how many? I think 4 spools now, more than it maybe, but I didn't face any issue, not a single one. So it could have disadvantage, but I'm not aware of it. And yeah, to be honest, when I'm thinking, I couldn't see any disadvantage except maybe except its price due to chip shortage in the world. Okay, let's continue with our topic. So this is the, by the way, GitHub page of the HUVUD made by Bondus. Now, like I said, it has 0.61 version. The difference is it has ADXL accelerometer on the board by default. So that means that You don't need to put extra ADXL board to make a resonance test, resonance compensation test. And other things, it has more and stop input. And in the input, this one of these pin is that one is 3.3 volt for the magnetic sensor instead of using mechanical switch and then stop. And with the new one, it is 5 volts. So for example, I'm using only mechanical one, so 5 volt, for example, can be used for the RGB LEDs on the start burner. Just an example. Of course, you can use there's a couple pins in here for the diagnose purposes and etc. But didn't have enough I/O in the board, and I'm using one of them as a end stop in my printer. So I'm using, by the way, 0.50 version, but the difference is only ADXL and more input output. The thing is, due to shortage, it is really hard to get one. So I could get one via Warren's flea market. And I can say that it's expensive since, yeah, due to market, but yeah, I just couldn't help to not getting because I just want to try it and I'm happy with it, to be honest. So it's, by the way, fed by 12 or 24 volts. So we are using 24 volts. It's also okay. As you can see, it has a USB connection. This USB is not for running your HUVUD board. This is only for flashing your HUVUD board. So since it is a small motherboard, you need to flash this HUVUD board also, like you are flashing your Phytex Spider, SKR or Octopus board. So once you flashed, it's good to go. So like I said, it is really hard to get this one, but luckily 3D Mellow developed one CAN bus board based on the HUVUD. I also couldn't help myself and get this one from the Mellow, and yeah, it's fairly cheap, I can say, because yeah, I got 0.50 for 50 euro, and this one is 38 euro. And yeah, this is basically, I can say that it is exact same with the 0.61 version. It has ADXL, more input output, that's all, and etc. And this board from the 3D Milo has two versions. One of them for these small circular motors. I couldn't remember the name, sorry. And one of them for the pancake motor. So I'm using this one since I'm using Clockwork one. But yeah, if you would like to go with this one, doing the same thing, but it's just a different shape. And these also has two options. One of them can support PT 100. I never used PT 100, I never needed it, but if you are willing to try it, yeah, it has the option that you can plug PT 100 in the CAN bus board. Also, same thing also for the board for the pancake motor. Now, as you can see, they have also selling extra boards. So what are these? These are actually CAN bus board for your Raspberry Pi. So Raspberry Pi has not hardware for the CAN bus communication protocol. With this, you are adding the CAN bus communication protocols hardware to your system. You are connecting your HUD board to this board, and this board is connected to your Raspberry Pi, and Clipper is doing all the magic and it's communicating via CAN bus. I'm using the WaveShares Pi head for the CAN. So this is pretty straightforward. It's head, huh? You are just placing this one on top of your Raspberry Pi, and basically that's all. But yeah, if you would like to try it, you can also try this one, the one from the Mellow. But I cannot say anything about that. I didn't try it, but I'm using the WaveShare ones without issue. Also, there is one simple, very cheap board. I think it is this one. Yeah, and also this simple small board also can be used. The thing is, for this you need to do some modification. You need to cut one trace of the copper on the back side of the board, and you need to solder a wire to feed it with the different voltage, because the one of the chip is fed by 3.3 and the other should be fed by 5 volts. So for 5 volt, you are cutting the trace and soldering it and feeding the 5 volts separately to board. Yeah, if you yeah, it's I did the modification. I tried it. It is working. But if I were you, I will go with the head. It is easier without hassling. Okay, but you have to have this CAN bus port, either this one or the Mellow one. So the like I said, this for example placed on the top of the Raspberry Pi, and you are feeding 24 volts to HUVUD board or this FLY-SHT board separately from the power supply directly, which I'm doing, and also the H and L. From here, you are going to do again HUVUD or yeah, I mean the CAN bus board. So with these two cables, you are communicating, sending and receiving data. So let me show you the. So I have the, like I said, I couldn't help myself, and I get one CAN bus port from the Mellow. So this is the package. I already opened it, but yeah, nothing special. So you are receiving, of course, the connectors, and yeah, since I opened it, now it's a little bit mixed. Yes, so not this, but you are getting this one. So you are getting these pins for the CAN cables and 24. These are for the JST for the extruder motor, and these are for the JST, small JST for the thermistor and the other stuff. And they are also sending this one. I'm not sure what it is. If you know, let me know in the comments. And of course, the board itself, the important thing. So this is the CAN board. This is the CAN and power cables you need to feed in. By the way, these are already plugged, so yeah, this is the male part. Don't, yeah, I mean, they are also sending all connectors and the pins. As you can see, the JSTs and the others also placed in place. So this is the board. Like I said, it has the same dimension with the stepper motors. So there is a STM and STM driver and the ADXL chip on it. Yeah, like I said, of course you can see there's a lot of I/O ports in here. So this is the board. Also, they are sending me one heat sink for the driver, of course. Yeah, this is the package. For using CAN bus, it's a little bit tricky. It's not hard, but while I was doing, for example, I stuck one issue with the mainsail. It's just a minor mistake, but it was really hard to debug it. It can be hard if there is no tutorial. So actually, that's why I am recording this one. So it's also a reference for me in the future if I want to change something. Okay, let's continue with how can we install our CAN bus board. So let's get started. This part can be done after you flash your main motherboard. So after that, you can proceed with this one. I guess it's convenient. So what we need to do, first of all, we need to add some uh, settings to create a CAN bus protocol in our Raspberry Pi. For that, just SSH to your Raspberry Pi and go to the create CAN 0 config file under the interfaces.d. Yeah, by the way, I will share these commands so you can just copy paste it. So of course it is asking for password since we do the sudo. So I already did it, but I'm just showing you. Normally there is no can0 file in your Raspberry Pi. When you enter this command, it's creating this file, and you will have empty txt file basically. So what you need to do, just copy this one. Again, I will share them. Copy this part and paste it in here, and with Control X, exit it. It will ask you to save it, the changes, accept it and save it. As a second step, we need to open our config file under the boot folder. Again, with the sudo nano, you can open it, and in here, we need to add this part, these two. You can directly copy paste this one but for the DT overlay, there's a thing. So you need to check, actually, let me show you. On the, for example, in the CAN bus, yeah, the wave share head, there is an oscillator. No, don't do that. Okay, there is an oscillator, this one. So on top of this one, why? Okay, on top of this gray thing, the oscillator, there is a number written, 2-digit dot 3-digit. So you need this number. So just took the card, read what it is, and you need it. After getting this number, you need to change this one according to what you have. So for example, I had 12 megahertz and I give input as a 12 million. So that means 12 hertz. And the interrupt is 25. This is the pin number basically. And the SPI frequency is 2 million. This line is for the 12 megahertz oscillator. If you have 8 megahertz oscillator, you need to change this one to 8 million, and you need to change the SPI max frequency to 1 million. That's all. There is only two options, 8 and 12. Yeah, both of them are explained and it will be written on the, you can just copy paste. Then after what I did, this was also giving me issue before because it was not creating the CAN bus port. If you are using mainsail, just command enable UART1 equals 1 and DT overlay disable BT. And also these two, DT overlay pi 3 disable BT, GPU mem 128 and GPU mem 128. I think it could be overkill to disable all this one, I'm not sure. Yeah, with that I could get it running, and like I said, I'm not running any issue. So somehow one of these settings was interrupting to my Raspberry Pi to create a CAN bus protocol. So you need to disable these and add these two lines. So yeah, actually enable UART I disabled here and pasted here. The purpose is these settings are related to each other, so I want to see them as a little bit organized. So that's why I put it like that. You can also not disable this one and only add this one, and you should be also okay. But this is more organized, I think, so that's why I did it like that. Okay, after doing these changes, again, hit Control X and it will ask you to save changes, accept it, and that's done. And as a next step, we will create a firmware for the HUVUD board this time. Not the motherboard, but the HUVUD board. For that, we can cheat from the documentation of Voron website. So we need to go to the Clipper folder. Let's go there. And we need to say make clean, then make menu config. So this will, of course, there is a space between. So this will give us this menu. So in here, we need to do the settings like we are doing in the main motherboard. So again, you need to enable it. If it is not enabled, the low level configuration, then you need to select STM32. And then you need to select for the HUVUD. Now, this is the HUVUD settings, and the CAN bus from the Mellow settings are different. So let's make it for first HUVUD so you can cheat it from it. So for the HUVUD, these are enabled STM32 and STM32-103. Then the bootloader offset with 8 kilobit bootloader, and the reference is 8 megahertz, and the communication interface is PB8, PB9, and the CAN bus speed 250,000 I am using. So this is the speed of the data transfer. I read that the 250,000 speed is more reliable. So that's why I am using the bitrate. I mean, that's why I'm using 250,000. I didn't face any issue like the toolhead is lacking something because of the missing information or latency of the coming information. So I can recommend to you use 250,000. I think it's more than enough, but also you can use 5,000 bitrate. But if you will use 5,000 bitrate, I forgot to tell you, now I will make it correct, but this is the HUVUD settings. So change the CAN bus speed by enter and give the value and enter. Then hit Q and hit Y to save it, and now the settings are done. So if you will use 500,000 bitrate, as you remember in the first step, we create a config file. So this one. If you are using 5000, change this bitrate to also 5000. This bitrate should be matching with this one should be matching with the settings and with it in the firmware part, the menu config part. If it is matching, that should be okay. But like I said, I would go again with the 250,000. But remember that these should be matching. Okay, we did what we did. We did prepared our settings to create a firmware. Then what we need to do, so for the HUVUD boards, we need to flash them via USB cable. Actually, before that, let me also show you what is the settings for the CAN bus board from the 3D Mellow. So for the CAN bus board from the Mellow, settings should be like that. Again, this should be enabled, and the microchip again is STM32, but the processor model is STM32F072, and bootloader offset is no bootloader, we need to select, and the clock reference is 8 MHz, and the communication interface is PB8, PB9 CAN bus, and the CAN bus speed depends on your choice, but remember it should be matching with the CAN0 config file. So these settings are for the CAN bus board from the 3D Mellow. So hit Y, yeah, same things. Now the firmware is ready. Let's assume we are flashing the CAN bus board from the 3D Mellow. Before starting flash, we need to shortcut with the jumper to legs. With that, our chip will go enter the boot mode. So for that, as it's shown in here, we need to put a jumper between these two legs. It's just next to big connector. These two legs needs to be shorted with the jumper, and in this one, these two. After putting jumper, just give power on the board and it will enter the bootload. As you can see now, I did a massive wiring to test and do no CAN bus board. Now I need to flash it with the firmware. For that I plug with the USB cable, and also you need to put a jumper in third one. When the connector is on your right side, the third one you need to put a jumper between these two legs and give the power cycle. You need to feed with the 24 volt. The USB power is not enough for the flash. I send LSUSB and to see, as you can see, I can see the STM device in DFU mode. After giving a power, send LSUSB. So right now my printer is running, so I cannot show you the actual picture, but you will get it what I meant. So this is the devices which are connected with the LSUSB, and in here you will see something like different, not these ones, but something with different. When you send the LSUSB, you will see this line STM microelectronics XTM device in DFU mode. So what you need to do, you need to take this ID. I don't know it is same for every device, so just run the LSUSB and see. But you need this 8-digit, actually 9-digit device ID. So with that ID, what you need to do, you need to make flash device command. If you are flashing HUVUD, it is same. The device ID is this one. You can directly copy paste this command and it will flash the HUVUD board. But for the CAN bus board from the Mellow, just type the device ID number in here like what you found in the LS-USB, and hit enter, and it will flash the firmware. And after that, yeah, it will take only a minute or something, only 60 seconds or something, and that's all. After it's finished, of course, as you know, it's the same thing with the flashing the spider or octopus. So you will recognize the output. So after it's finished, you need to remove the power from the CAN bus port. You need to remove the jumper that you put for the entering the boot mode, which is this one. And again, of course, you need to also remove the USB cable. And after that, you need to give the power again. With that, right now, your firmware is flashed on the Hoot CAN bus port, and your Raspberry Pi should has also CAN bus interface. By the way, if you send ifconfig, for example, you need to see this protocol in here, interface in here with the CAN 0. Like I said, you are flashing your CAN bus port via USB, so you need to also plug the USB cable here and the other end in the Raspberry Pi. And after that, you will just remove it, but because it's useless. Let's move on because it's not finished yet. In here, we need one command to find the device ID of our CAN bus port. For that, you need to run this command, and it won't work for me right now since my printer is active, I mean running printing, but it will give you a device ID. So instead of 0UUID found, it will say UUID, and this is the UID. And you need to take this ID and define the motherboard in your config file. So this is my printer config, like you are doing for the motherboard, you need to do for the CAN bus port. So I named my CAN bus port as a TH, stands for toolhead, and you need to enter CAN bus UUID equals to whatever your device ID is. Then after that, change the pins. So what do you need to change? It's, for example, in my case, it is connecting the toolhead. So in extruder, as you can see, my extruder motor is defined the pins on the toolhead, which is the HUVUD board. Actually, we can do that. Yep. And of course, my heater is on there. My thermistor is on there. And again, this is for stepper motors are there. Let's do a quick find. Yeah, and in my case, the my X and stub is connected to HUD port. That's why it's defined for the 2TH as a pin. And yeah, that's all. So you need, yeah, basically you need to edit your config via the information. So where you can get the pinout. So you need to pinout for edit your config file. So in for HUVUD, in the main page of the repository, there is a pinout and lookup. So in here, it is defined. So these are the stepper, and yeah, CAN is PB8, PB9, we already defined it. And these are the fans. If you connect to the cooling fan in here, so the pin for the cooling fan is PA8, like that. The other fan, the heater, and stop if you are using it, and the thermistor, of course. And I'm using one of these pin for the clicky probe. So yeah, you can also use the inductive probe, the Omron probe, for example. But don't forget to put BET85, and also don't forget it's fed by 24 volts, so you need to do a little bit wiring in there, and don't forget it. But I switched to clicker probe, so it doesn't require any BET85 or 24 volt. It's straightforward, it's just mechanical switch. Yeah, after editing your config, yeah, you should be fine. I don't know why my the mainsail is very heavy in this print, but yeah, okay. So as you can see, it is running at the moment. It is the board, the toolhead is connected to HUVUD board, in my case 0.50. So like I said, clicky probe is connected to HUVUD, and X and stub is connected to HUVUD, and heater is connected to HUVUD, thermistor is connected to HUVUD, but yeah, you can see the reading, and of course the hot and cooling fan is connected to HUVUD, and also of course the extruder motor is connected to HUVUD. And beside that, I ran another wire for my RGB LEDs on the stealth burner because most probably I could use another pin for data, but anyway I need cable for 5 volts, so I just run 5 volt and data cable from main motherboard, and I'm sharing the same GND with the HUD board. So except the RGB LED on my build, it's all connected to HUD board. But yeah, for example, if I got this one, the HUD from the CAN bus port from the Mellow, I could also connect the RGB in the CAN bus port because it has 5-volt output, or if I had the 0.61 version. Like I said, I will share the links. You can dig down for the HUVUD or CAN bus from the Mellow. You can see how they are doing it. Yeah, you can check it out these websites, and of course the CAN bus interface for the clipper. You can check them. But I will make also a tutorial, a written tutorial, so that you can just simply copy and paste commands and for example, this stuff, you can just directly copy paste it. I will be sharing this one on my GitHub repository, so I will share the link in the description. You can just go there and do the steps and you should be fine. For now, I don't know how you can get the HUD board. I'm not sure it's available again, which I'm guessing not. But the canvas from the Mellow is available at the moment in the AliExpress. You can buy from them if you want, if you would like to try. So that was all for today. If you have any question or remark, just let me know in the comments. And thank you for watching and see you on the next one.